I'd love to introduce Oluwatoyin Sanni, who will talk to us about the role of... So Oluwatoyin Sanni is currently an AI and robotics research student at Sapienza University of Rome, a GHC 2020 scholar and a 2019 Google WTM scholar. Prior to her studies, she's worked as a software developer and technical team lead at Andela. She was also the co-founder of Tech in Pink, an initiative dedicated to mentoring and supporting young women interested in programming. And she's also the co-founder of the Lagos Women in Machine Learning and Data Science workshops. So in this talk, she'll be giving technical insights to the applications of AI and robotics in the health center. Thank you so much, Yeti, for being with us today. And please, the floor is yours.
Thank you. It's my great pleasure. And now I will be sharing my screen. Please confirm if you can see my screen.
It's looking good, Yeti. Thank you.
Awesome. Hi, everyone. Welcome to this talk where I'll be giving insights to the role of AI, which is artificial intelligence, and soft robotics and microrobotics in the healthcare. As you have said, as introduced earlier, I'm currently an AI and robotics research student at Sapienza University of Rome. What is this talk going to be about? I would give 6 technical terminologies that would guide our talk today. I would also give 4 brief applications of these technologies that I've mentioned earlier. And I'll also give 2 technical backgrounds to my past research work and current research work, and then a conclusion. AI generally is a branch of computer science where we are trying to make a machine smart like a human. Why not? Why don't we have machines who could depict human intelligence? And that is what AI is about. And soft robotics, let me minimize this. Okay. Soft robotics is a subfield of robotics that deals with constructing robots that have compliant materials with the kind of cells and the kind of thing you find in living organisms like humans. And microrobotics, like the name micro, is basically robots that are less than 1 meter, 1 millimeter. As we can see in this picture, this is actually an example of what a microrobot looks like. And the 4th terminology is robot kinematics, which is basically the study of all the possible motions of a robot. As we can see here, this is like a robot arm. And the only difference is that the arm here is what we call an end effector, which is like the palm that you would have with our ends. For the 5th and 6th terminology, I'm going to give a pause on this and talk about it later on in the slides. Looking at this game, we have an agent, we have orders, which we would call obstacles, and we have this diamond. We all love diamonds, right? And the goal of this agent is basically to go through this grid, this environment, to get the goal. However, from an human first glance, it's easy for us to say, oh, the robot just have to go up and right and right and down and right. However, for a robot, it's dumb at the very first start. The robot doesn't know what to do. It doesn't know how the environment is. And this is where reinforcement learning comes in. Basically, we want this robot, which is initially dumb, we want it to be smart, just like us, that have gone through this grid to get to the diamond. How is this done? We have what we call a reward policy, where this robot gets positive and negative reward based on the movement, which we call actions in this environment. For example, if the robot goes through any of the grid where we have this obstacle, the robot is going to get a negative reward. However, when it goes through a grid that doesn't have any of these obstacles, it gets a positive reward. And at the end of the day, we repeat lot and lot of exploitation and exploration, and finally make our dumb robots depict the kind of intelligence that we would do when we are put in this situation. This video that we see here is basically me in one of the lab in my university. And this is what we call a teleoperation. We have a robot, a medical robot called Da Vinci robot. In Da Vinci robot, we see a surgeon who is actually operating on a patient. However, this doctor make use of a console like we see in my hands here. Instead of operating directly on the patient, the surgeon uses a joystick. Why do we have to use a joystick? The reason why we have to use a joystick is that the joystick gives constraints and it allows precision and accuracy such that the surgeon is not using the instrument more than they should not go more than the centimeter they should go, or less than the required centimeter that they should go in the body of the patient. So this is how teleoperation is done. Now I'm going to give 4 different, this is the application of AI and robotics to the healthcare is not limited to these 4 ways, but however, these are the most common ways where we see the applications of AI and robotics. In the place of diagnosis, AI can be used to for malaria diagnosis using neural networks. And can you still hear me? Because I can see my network is a bit unstable. Please, can you confirm?
Yes,
Can
we
you
can
confirm?
see it. Yes, we can see it. Yes, thank you.
Okay, awesome. All right, let's go on. And AI can be used in malaria diagnosis in terms of analyzing images. It can also be used in what we call expert systems. For example, during my undergraduate studies, my project was a dental expert system where we have a patient with tooth problems come to give the system the kind of symptoms that they are having. And on selection of the symptoms that they experience, the system is able to give the most likeliable disease that is wrong with their tooth. So this is how AI diagnoses in some cases. Also in diagnosis, soft robotics can be used for breast palpation, which is also known as breast examination to detect cancerous tissues. Nanorobotics, however, is one of the research that is ongoing for different purposes. For now, we use nanorobotics, we use it in performing experiments with animals and not humans yet. And nanorobotics, as I said earlier, are less than 1 millimeter, and they can actually be used like a drug where it goes into the human body and is able to detect if there are cancerous tissues in the body. In terms of treatments, AI can be used for drug discovery. In some years back for soft robotics, a university in Sweden have been able to actually produce, using soft robotics, produce a tracheate system in a human, and this works perfectly. It can also be used as, soft robotics is also used in treatments and producing exoskeletons to help people who have disabilities. Nanorobotics in treatment can also be used to deliver anti-cancer drugs and also in pharmacokinetics, which is a method where we are trying to see how the body can react to a particular drug. In terms of early detection, there is an ongoing research with a professor in South Africa in University of Johannesburg, where the professor is, the lab is trying to analyze 3D images of newborn. And they're trying to see how 3D images of newborn can actually be used to detect different kind of disorders that the patient, that the baby can be prone to, disorders like autism or ADHD and the rest. Soft robotics, it can also be used in early detection, like I said earlier, in breast examination. And nanorobotics, an application is nanosensors that could be sent into the body to detect if the human is prone to any kind of disease. As we see in this picture, this depicts the video that I shared earlier of me in one of our laboratory. We will see that there is a surgeon here and he has a console like a joystick that you see in my hand. There is a camera view, there is a nurse who is assisting the surgeon, and the surgeon is basically controlling all of these tools on the patient without being there, but actually from this console. This console actually controls the constraints and controls the precision, gives precision and accuracy to the tools that the surgeon is using on the patient. And this is teleoperation in soft robotics. In AI, we have seen cases like, for example, the COVID-19. AI has been used for advanced imaging and molecular analysis. AI has also been used to create different variants of the SARS virus to see how it can be combated. Nanorobotics in assisted surgery can also be used to transport and release certain type of cells before a surgery is done. Now we're going to talk about research work that I've done in the past. Prior to my studies, when I was working at Andela, I worked on malaria diagnosis using AI. And the second project that I'm currently working on is with the Intelligence Manipulation Laboratory at Lincoln University, where we are trying to come up with an advanced robotic breast examination intelligence system. The first project I'll talk about is the malaria diagnosis. Why did I pick this project? First of all, this was my first step into research because I was curious about solving problems in the health sector. And malaria is one of the top leading causes of death in sub-Saharan Africa. The motivation is that I was able to actually find prior research work that had applied AI, and my job was to actually improve this previous method. Also, this brings about faster diagnosis. Instead of some places in Africa, if you want to do a malaria test, it takes more than 24 hours. However, this system brings you faster diagnosis. Also, is a cheaper alternative using smartphones instead of the microscopic equipment that we use in the lab. The data that was used for this project was images of both thick and thin blood smears. As we see in this image, we have 4 different types of malaria parasites in 3 different stages. So we had thick and thin blood smears that were grouped into negative, that is no malaria parasite, or one of this class that we see here. The architecture of this, while I don't want to go into details of the architecture of this project, the architecture is what we see in this image, and this is let's say a compression of different neural network methods. And I use the concept called transfer learning. Transfer learning is basically when you use a system that has been trained on a previous related data. And this was to improve the research that I found earlier before I started the project. What is the status of this project? Well, it has not been commercialized because we have ethics rules that govern the use of AI for health. And moreover, it is a system that had to go through different bodies before it can be commercialized and used in the laboratories. The current research that I'm working on, which I really love, is called Artemis. Like I said earlier, I and the team and my team members are trying to develop an intelligent robotic system that will help early breast cancer detection. Early breast cancer detection helps us to reduce the incidence rate of stage 4 breast cancer morbidity and mortality. That is, we are trying to reduce the number of people that enter into the stage 4 breast cancer. For example, maybe not all of us are aware of Angelina Jolie, who is an actress, and she went through this test called the BRCA gene, which is to see how your genes are prone to to breast cancer. And because she did this test, she was able to know that she was prone to breast cancer. She was able to do prophylactic mastectomy. Now we're going to talk about the fifth and sixth terminologies. Like I said earlier, in the grid, in the game that we were trying to play to get to the diamond, our agent exploits and explore the environment in different episodes before it can actually learn. It has to go through different episodes, different learning patterns to know the reward policy, to know what policy should I actually follow before I can get to my goal. But actually, we have the opposite of reinforcement learning, which is inverse reinforcement learning. Inverse reinforcement learning is basically when we bring in an agent. So instead of having a robot explore the grid before it can understand the environment to get to the goal, we bring in an expert, which is, in this case, for Artemis, is a doctor who can perform breast palpation. And in this case, we are actually not exploring or exploiting. We are actually bringing someone who is an expert, who is good at this game, who is good at doing breast palpation. And we have this agent learn from these experts. And this is what our project is. This is the technology that Artemis is going to be using. As we see in this image, this is not a real breast. This is what we call a phantom breast, because it's a phantom breast with sensors. And an expert comes in and do a circular motion on this breast phantom, applying different pressure in different areas of the breast. And we teach that techniques that the expert is doing on this phantom. We teach the same techniques to the robot, to our agents. In this method, we are trying to make sure that when we teach our agent, number one, the AI comes in from the inverse reinforcement learning method of learning the right policy from the expert. Secondly, the soft robotics approach is in the end effector of the robot, whereby we are making sure that whatever palms we are giving our robots is not the type you see on an industrial robot, but something that is compliant with the human body. After all, we want to make sure that our robot doesn't puncture or apply too much force on our patient breast. And we also want to make sure that when the robot is applying the pressure, it's applying the right kind of pressure on the different part of the breast of the patient. What is the current status of this project? Right now, we're gathering the required technical knowledge as a team, and then we move to the phase of bringing in an expert who will actually give us the data that we need to learn the right policy to give our robot. And then we move to the building of the architecture for the project, and finally, putting it to good use for humanity. So in this talk, I've shared different ways that AI, soft robotics, and micro robotics are very useful technologies in the health sector. I like this quote from Amit Ray, which says, "Compassionate AI drives the machines to cry for those who are in pain and suffering. It drives the machine to find the shortest path to minimize the pain and suffering of others." And this is one of the goals at the lab, to build and use AI, robotics, to build solutions and reduce the pain of humanity. Thank you so much for listening. Here you will find my email if you have more questions, and this is the website to our lab if you want to check the other work that we are doing. Thank you so much for listening. And now I will be glad to take questions.
Thank you so much, Yeti. That was fascinating. Well, we have our first question. What has been the most challenging part of teaching the robot how to do breast exams?
Oh, so like I said earlier, this is a project that we are currently working on. But I already see challenges in this problem. As a researcher, when you check other people's related work, you know what could be wrong. And the most difficult part of it, I believe, is going to be in learning the right policy. This is because we have different now I'm trying to we have different people with different shapes of breast. We have people with different sizes of breast. So this means that when we bring in an expert, we want to expose them to all of these varieties, and we want to maximize and make sure that the policy that we give these agents is actually going to be applicable to the different kind of patients that the robot has to deal with. So this is one of the challenges that I already see with the project.
Thank you. And Shavani is asking, what are the upcoming work that you are excited about? What have you got planned for this year or next?
Okay, I'm currently a student, and this is what I'm working on now is my thesis, which is on medical robotics. But I am very excited I'm heavily invested in using AI and robotics to solve problems in the healthcare system. And one of the things that maybe not this year, but one of the things that I'm very excited about is actually coming up with an AI diagnosis center in Africa that could actually solve some of our health related problems. So I'm very much excited about doing that. So.
There's also another question from Ukachi. What prior project did you use for transfer learning while working on malaria diagnosis?
Can you please repeat the question?
Sure. What prior project did you use for transfer learning while working on malaria diagnosis?
Okay. It was actually a project from Uganda. It was from, now I forgot the name, I'm so sorry. Maybe if this person can send me an email, I'm going to actually send a lab where I got the data that I used. But it was actually from a university in Uganda.
Okay, and I'm actually interested myself with the malaria diagnosis. Could that also be applied to other mosquito-transmitted disease? I live in Mexico, and there's a lot of dengue and also chikungunya here. Some cases of Zika, but I think probably the majority of the people I know have had dengue at least once now, and also some who have really suffered from chikungunya, and just wondering whether that same process could be used with other mosquito diseases.
I wouldn't say yes or no. It would depend on the manual method that has been used. So the reason why neural networks, convolutional neural networks, or the approach that I used for the diagnosis was quite straightforward was because the usual method would be taking the blood sample and putting some chemicals on the blood sample and inspecting it under a microscopic equipment. So this when I want to upscale this traditional method to AI, then I want to move to images analysis. So if I'm sorry, I don't know about these names that you've mentioned, but I believe that if the traditional, it just depends on looking at the traditional method that has been used to diagnose and seeing how that can be upscaled in maybe images or different, in different form where AI can come in. But well, I like to believe AI can be used to solve a lot of problems. So probably that would be yes.
Thank you. Does anybody else have any questions for Yeti? You can also raise your hand and we can unmute you, or you can drop a question quickly in the chat box. We still have a couple of minutes time. Also, I'm interested in the robotic surgeons. What is the like room for error, like when you compare a robotic surgeon to a human surgeon?
Okay, when it comes to, so for now, we don't have 100% robotic surgeon. We don't have a case where we leave a patient to we leave a patient to a robot. What we have is actually a synergy between the surgeon and the robotic application. Like I said, it's not like we want to eradicate the doctors, because there are cases where you need to make decisions that only the human mind can really come up with. So we don't want to take that away. But how this synergy comes together is when like I said, gives precision and accuracy to the surgeon, such that, for example, if I'm performing an operation on a patient and I'm not supposed to go more than 5 centimeters into the particular organ that I'm working on, even when I'm where the surgical robot application comes in is even when I'm making error of going more than how I should go, there is a restriction. So as a surgeon, you would see that your instrument is actually not moving. And that is a sign that the robot is trying to say, that should not be, because this is the constraint that you have given me concerning this surgery that you're doing. I hope I answered the question.
Thank you. It's all very fascinating. Well, thank you so much. If anybody else has a really quick question, we've got about a minute. I think we have Shavani just wishing you all the best, Yeti. All the best with all your research. Thank you so much for joining us here at our virtual summit and kicking off our engineering track for today. So thank you so much for participating, and we wish you all the best, Yeti.
It's my great pleasure. Thank you so much, everyone, for joining.